In this video, we are going to review the integration by parts technique. So integration by part technique is one of the very important method in integral calculus. So there are certain integrals that you cannot do without integration by parts technique. So we can look at some of them in the video. So we can do 6 problems. So let's look at the formula first. So the formula is the integral of u with respect to v equal uv minus the integral of v with respect to u. So you switch the order. So that's what happened. So why we need this one is, normally what happen is the first integral is difficult. So you have a difficult integral, and what you can do, you can transform into a easy integral, because sometimes what happen when you switch the two functions, maybe the second one is easy. So that's the whole point. So you try to make the second integral is easy to integrate compared to the first one. And how do you know which one we're going to pick as u? So we can use the acronym LIATE for this one. So LIATE, LIATE. So what this LIATE means? So for L means the log. So L means the log, and the I means the inverse trig functions, and the A means the algebraic expression. So there are some algebraic expressions, and the T means the trigonometric expressions, and then E means the exponential one. So so this is the priority order for U. So this is how we're going to pick U. So that means if you see a log term, we're going to pick this one as the very first one. And if you see the exponential, we're going to pick that one as the last one. But this not always 100% work. This works most of the time. I should say like 99% of the time this can work. So let's look at some examples now and try to understand what's really going on here. So let's look at the first example. So as the first one, we have x sin x dx. So according to the argument, you can clearly see that algebraic expressions comes before the trig formulas. So that means the first one we're going to pick as u, the next one is the dv term. So that's how we're going to pick u and dv. And after we pick this one, what we do normally, we're going to say u equal x, and then what we do, we take the derivative. So it's a du over dx, which is equals to 1, and then we cross multiply. So we kind of think of this as a ratio and write it like that. So that's the first step. You pick u and then take the derivative and solve for du. And for the other one, what we do, we have dv is sin x dx. So what we do here, we take the integral. So we integrate this one, both sides. So we can integrate dv, and we can integrate sin x dx. So we're going to get v. If you integrate dv, you get v. And then integral of sine. Integral of sine means negative cosine. So and we write it like that. And if you are not familiar with this why sine has negative cosine, you need to remember those common integrals that you can see in calculus. And I have put a link in the description. You can find them and remember them. So this is the argument. So what we do here, so we have those. So we start with u and get the du. We start with dv and get the v. So these are the four things. Now what we can do, we're going to plug into the formula. So let's go to the formula and plug in them. So the formula says u dv equals to uv minus v du. So we can plug in here. So if you plug in uv, we know what is u function, what is v function. So you multiply the two functions. So when you multiply them, you get negative x cosine x, and then minus, there's a minus sign, and then v du. V means negative cosine x dx. So now what happen is negative x cosine x, negative positive. So you can write it like that. This step is unnecessary, but I write it just for completeness. And you can see this is negative x cosine x. Integral of cosine is again, we know the integral of cosine, so it is sin x. So which is sin x plus c. So you have the c at the end. So that's how you do the problem using this method. And what formulas we use here? So we use one formula, which is the integral of sin x, which is negative cosine x plus c. we also use the integral of cosine x, which is the sin x plus c. So those are the formulas we use. So let's look at the second example now. The second example, we have the integral of 2t plus 3 e to the negative t dt. And then according to LIATE, and you can see that we have algebraic expression and exponential one. So that means we're going to take the algebraic one as the u and the rest of the them as the dv. So that means we can write u equal 2t plus 3. So we take the derivative and then we can write this one as du equal 2 dt after the derivative and multiply. And then the rest we have dv, which is e to the negative t dt, and then we're going to take the integral of this one. So which is the integral, we get v equal, in this case k equal negative 1. So we divide by negative 1, or that means multiply by negative 1 in this case because it's 1. That's what we get. So so what formula we use here? We use the formula e to the kt, e to the kx as a formula, k to the ex dx equal 1 over k e to the kx plus c. But we don't write the c when you write the when you find v, u and v. Now if you use the formula, so you can see the, so we can plug in here. So it is uv minus v du, the integral. So that means it is equals to uv. So that means it is negative 2t plus 3 e to the negative t minus v. V means negative et. So that means you're going to get negative become positive. So you get e to the negative t, and then there's a 2. You can write the 2 outside, and then dt. So that means if you simplify, you can get negative 2t plus 3 e to the negative t, and then negative 2e negative t plus c. And if you can simply, if you want, you can simplify this one. So it is all negative, and you can pull e to the negative t out, and then you're going to get 2t, and negative 3 negative 2 means negative. Actually so it is negative because negative is an out, is positive 5 plus c. So that's the answer for this problem. Next we have a log one. So you can see we have like ln x here, and then according to LIATE, remember, like when you have a log expression, that's exactly what we're going to use as the u. So that means this is going to be the u term. So what we normally do is we're gonna you can switch the order. You don't have to write this step, but we can do that. We can switch the order, so we can write ln u, and then we have x square root of x cubed. So it is x to the 3 half dx. You can write it like that, and then clearly this is the u term, and then this is the dv term. So if you write it, you're going to get u equal ln x, and then dv equal, we have x to the 3 halves dx. So we take the derivative of the first one, so that means we can write this one as du equal derivative of ln x is 1 over x dx, and then v, so you're going to add 1 and divide, so it's going to be 2/5 x to the 5 half. So then we can write the final answer now. So it's going to be, so we have x3 square root ln x dx equal so it is uv minus v du. So uv in this case is 2/5 x 5 half times ln x, that's the u and v. So the u and v, and then minus v du. So minus v du. So we write the numbers in outside. So we have 1/2, so which is x 5 half, that's the v. Du is 1 over x dx, and you will see this is exactly the reason why we selected ln x as the u term, because you can see the 1 over x terms appear here. Now you can see you can cancel, you can simplify it well. So you can cancel one of them. So that means you're going to get the final answer as 2/5 x to the 5/2 ln x minus, see what happens when you simplify, you get you get x to the 3/2 again, and then dx. Now you can integrate again, so you will see, so you're going to get 2/5 x 5/2 ln x. So if you integrate, and you can see you get another 2/5, so it's going to be 4/25 x to the 5/2 plus c. So you can leave it like this as the answer. There's nothing wrong with that. Also, if you want, you can actually simplify this a little bit. You can see x to the 5/2 divided by 25 is a common factor. So we can take the common denominator and write it like that. And then, so that means you can write this one as x to the 5th square root divided by 25. And then inside you're gonna get so you're gonna get, because you put also 2. Actually, you can also pull 2 out. So let's write it like this. So I'm gonna change this to, you can write this one as 2/25, and then x to the 5th power, and then to the root, and then inside you're gonna get ln x minus 2 plus c. So you can write this one as the final answer for this one, ln x minus 2. Okay, so you can simplify this one really nicely. Okay, so let's look at the next one. So as the next one, we have u tan inverse u du. So you might be careful, you have to be very careful with this one, because you might see like we have u here, but we just use still the same symbol. So but when you have inverse trig according to LIATE, when you have inverse trig and a algebraic expression, you can see according to LIATE, you will see inverse trig as the u term. And so that means we can say u equal tan inverse u. Be careful with this one, these two u have two different meaning. So that's the u term, and everything else you're going to take as dv. So that means dv in this case is u du. Again, they have different meaning. So just do the same thing as before. So take the derivative. So take the derivative of tan inverse. That means it is going to be 1 plus u squared, in this case du. So be careful, the two different meaning. And then if you take the integral, you can see this is v equal u squared over 2. We don't add the c. Okay. So now we can write the formula for this one. So you can see, so that means your integral is u tan inverse u du equal uv product, which is u squared over 2 tan inverse u minus v du, 1/2, we can write it outside, and then from v you get a u squared term, from du you get 1 plus u squared term, and then the du. So this is what you get. And then you see you have another integral here. You need to integrate this one. So another question, how are you going to do something like that? So we can use like a simple algebra trick here. So what we're going to do, so you can write this one as, so we rewrite the first one, no change here. So that's the first one. For the second one, we do this interesting trick. What we're going to do, we're going to add and subtract 1. So we're going to add and subtract 1 to recreate the denominator. So you add 1, and then we have the u squared term, and then also we're going to subtract 1. So add and subtract 1. And then you can see, you can you can have like a parenthesis around this, like this. So we can parenthesize this. You can see that's the like same term as the denominator. That means if you divide, so you can see, you can write this one as u squared over 2 tan inverse u minus 1/2. This is simply going to be the integral, for the integral. So integral of 1 minus 1 over u squared. So you can write it like that. That's the reason why we want add and subtract. Because whatever in the parentheses, if you divide by the bottom, you get 1, and your leftover is -1, so -1 over. And then you can see this is very easy to integrate now. That means your answer is u squared over 2 tan inverse u minus 1/2 u, and then negative positive, and then 1/2 tan inverse u plus c. And you can also combine if you want these two. So yep, so that's the answer for that one. And remember the algebra trick we use for this one. You add and subtract one. So add and subtract, because this is equal to 0, so you can do that. Okay, so let's do maybe one more problem, just to kind of cover like all different types. Yeah, so we probably do like 2 more. So let's look at this special one. So we have a very special integral now. So the next one is, we have secant cube x dx. So and we don't see anything else. So we're gonna do like a special treatment for this one. So the idea is, we wanna rewrite this one so that one is easy to integrate, one is easy to differentiate. For example, how we do that? We're gonna pull out a secant term, and then we leave secant squared term. You may wonder why we did this, and it may be very clear. You can see this term, the second term, is very easy to integrate, because if you integrate secant squared, you get tan x, and this one is easy to differentiate. So you can see. So that means this is exactly the idea here. We're gonna pick one as the u term and the other one as the du term. So let's do that. So in this case, u equals secant x, and then dv equal secant squared x dx, or du, or you can say this is u and dv. You can write it like that. Okay, good. So take the derivative. So du equal secant x tan x dx, and if it is the integral, v is simply tan x. So we can substitute that now. So if you substitute, you can see your integral secant cube x dx going to be uv means secant x tan x, that's the uv term, minus v du. So v means tan x, du means secant x tan x dx. What is the next step? You can see you can combine these two, tan and tan. So we can write this one as secant x tan x minus, so it is tan squared x secant x dx. Now what I'm going to do, we're going to use one of the trigonometric identity. We know that the tan squared x is equal to secant squared minus 1, because we know that the secant squared x equals to 1 plus tan x, tan squared x. Because of that, you can write this one. So you can write this one as, I'm just repeating these first terms, secant x tan x minus, you can see this one as secant squared x minus 1 secant x dx. So now we're going to distribute. Once you distribute, you can see you get a secant cube term. See the secant cube term? So that secant cube term with the minus sign, I'm going to bring that to the other side. So if you bring the other side, you get 2 secant cube x, 2 secant cube x dx equals, so that's the idea, you get 2. So here you have a secant x tan x minus the integral of, actually so not minus, because there's a minus sign inside, minus sign outside. So so that means it's going to be plus secant x, and we know the integral of secant x from the table, so that means it's going to be secant x tan x plus, see, integral of secant is natural log secant plus tan, secant x plus tan x, and then what we can do, we can divide by 2 now. So if you divide by 2, you get the final answer. So it is secant cube x dx equals to 1/2 secant x tan x plus 1/2 natural log secant x plus tan x plus c. So this is like a very special treatment. So that's how we do it, and you can see like how the entire process work. So it's like a very neat, but we use for this one we use integration by parts, and it is little lengthy, but it's not very difficult. So we make the special choice of u equals secant x and the dv equals secant squared x, because one is easy to take the derivative, one is easy to take the integral. So that's how we do the problem. So let's just do one more problem just to finalize this idea. So this is the last example we do. So as the last one of this type, we have this special integral. We have integral of x plus 1 square root of x minus 1. And if you get a problem like that, actually you can do this problem in several different ways. You can use a substitution method. You can substitute for x minus 1 and then rewrite the integral using u, the whole integral. Or you can substitute for square root of x minus 1. That's the other way to do it. And then see whether you can do those two substitution methods and try to get the answer. But here we can use this one, use the integration by parts. So what we can do is we're gonna select the obvious choice here. So the obvious choice is we're gonna pick this one as u term, because once you take the derivative, it's gonna be much simple. And then this part is going to be dv part. So let's write u equal x plus 1. Take the derivative, du equal dx. So that's the whole point here. And the dv, which is x minus 1 to the 1/2 power dx. So that means v equal, if you integrate 2/3 x minus 1 3/2. Now we have everything we need. We just need to plug in them. So we can write the final answer now. So we have a uv, which is 2/3 x plus 1 times x minus 1 to the 3/2 minus a v du. I write the number outside, and then v, which is x minus 1 to the 3/2 du is dx. So you can see the second integral is easy to integrate, and so we write the answer is 2/3 x plus 1 x minus 1 to the 3/2, and here you're gonna get because you're gonna get 5/2, so that means it's gonna be 415 x minus 1 to the 5/2 plus c as the answer. Okay, so that's how we use integration parts to do this problem. Also try the other method, substitution. So we can also use the u sub for this one. One option is take u equal the inside function of the square root. That's one way. Or you can also try u equal the whole expression, u minus 1 square root, and see whether use these two techniques and see whether you can get the answer using the substitution method for this one as well. Yeah. Okay, so that's how you do the problem using integration by parts. Thank you.